Righto, so here we have my replacement for dry ice in my vacuum freeze drying system. Don't know if it's going to work. I do know that it's extremely noisy. So that's it. That will be at -30, hopefully. This esky will be at -10. So here is a 800 watt chiller. So it's pumping ethylene glycol through a radiator in this esky. And then inside that esky is a smaller 400 watt chiller, which is pumping ethanol through this pump into the dry ice there. So just one of these chillers by themselves can get down to -10 from like 25 ambient. So I'm hoping that two of them chained together this way will be able to get us all the way down. So inside here we've got the chiller there, and then the control board over there, and a fan and a radiator here. And so the idea is that this whole box will get to -10, which is as low as this can go, and then that smaller chiller can go all the way down. And so this reservoir here is the ethylene glycol. There's a submersion pump in there, so it's pumping it through that loop from here through the radiator. Then the radiator gets the cold blowing off it by a fan. It's not very scientific. That cools down the chiller in there, and then that chiller cools down this even further. So it's been running for about 10 minutes now, and we're down to 3.3. So yeah, so there we go. Alright, it's been running for about 2 hours now, and this is not successful. So the actual cold bath only got down to -10.9. The air inside the esky was positive 2.2 degrees, though the glycol running through the radiator in the esky was at -13.4, and the compressor on the 800 watt chiller was at 65, which is fine. They can get up to about 100 happily, and it's 26 degrees ambient. So if you're fridgy minded, you've probably already worked out what the problem is, given this is at -13 and the air in here is at +4. My radiator has completely iced up, so my esky is not sufficiently protecting it from atmospheric moisture, so it basically just stopped doing the job, stopped exchanging coolth, and has frozen solid. The glycol is still liquid, so it was still flowing through it, but there's no capacity for air to flow through that radiator. So that sucks. I need to do a better job of sealing the lid, I guess, or having some other means of interfacing the outer cold loop with the inner cold loop that isn't just the air, because basically I just need to get the heat off this radiator into this radiator, and using air as the medium works well as long as the air can actually flow through. So I could fill this esky with glycol and submerge this in it. However, I don't think that would be good for insulation. Yeah, I don't know. I have to have a think. Righto. Well, this is a worthwhile experiment. The lid is some of this high insulation performance insulation foam, but I didn't do a great job of cutting it out, and yeah, it's quite a lot of breathing happening there. But even if that were perfect, I suspect that given that the atmospheric moisture here is at about 70%, 60% at the moment, I'd have to, I mean, there'd be enough water in the air in there already to significantly impede the airflow through the radiator. But yeah, so what we got. It's already started to melt though. I know, something to think about. But that was fun getting all this set up. I did have to cannibalize that pump. That's the water pump out of my laser cutter. It runs the jacket cooling loop. We've got another one on the way. But yeah. Alright. Well, that's it. Bye bye.